So I'll begin with then the theory of firm today. This is a completely new start. Even if you have missed your consumer theory, try and pick it up from here now. So we begin with, first of all, what is a production function? So, first of all, mathematically speaking, a function is a relationship between dependent and independent variables. So when I say y is a function of x, it means as I vary x, it is going to vary y. So when I say that I am talking about a production function, I am saying that it is a functional relationship between input and output. So I am saying that, okay, I have an output that I want to produce. To produce this output, I need some inputs. My inputs can be labor and capital. So how is this output going to change when there is change in labor or capital? That is the production function. Now, ideally speaking, when we go to development economics, we will notice that y is a function of labor, capital, technology, different things, population, whatever, So in macroeconomics, we extend it to many variables. In microeconomics, we have a tendency of keeping it up to two variables, only labor and capital. Now, when it comes to the production function, we are always interested in finding that y, which is the maximum value for given ln k. So for example, if I tell you that one combination is that labor is 5, capital is 6, and output is 30. And I tell you that the other combination is labor 6, capital 6, output 30. Then this point, this should not be a part of my production function. Because here, for lesser labor and capital, I am able to generate the maximum output. Even with one less labor, I am able to generate 30 units of output. So there is no reason for me to be on the inefficient part. I don't want to be where I'm using more labor and capital. So the officially, when we write the definition of production function, we say it is the relation between quantity of input and output to produce maximum possible quantity of output. This is important. I only want to produce the efficient levels of output from the given level of inputs. Now, when it comes to efficient production, then we have two main ways of defining efficiency. First, either I can say that to produce the given level of output, I cannot reduce input any further. So for example, if I am producing output of 100 using labor 50 and capital 50, then I cannot produce 100 using any less labor or capital. This is the minimum labor and capital required to produce 100, then it is efficient production. And the second is that if you give me some level of inputs, then I am producing the maximum output. So they're synonymous. It's just different ways of saying it. The first is saying that for this output, I am producing it with minimum amount of input. इससे कम labor capital cannot be used. The second is saying that if you tell me that labor and capital is 50, what is the maximum output I can produce? I am putting that. So minimum input or maximum output. And once I know this efficient production, only these efficient production will go on production function. So only those LK combinations which satisfy this or this, LKY combinations, they will go on my production function. Now just think. See, ideally, when I say Y is a function of labor and capital, you'll do this again in maths. But just supposedly I tell you Y is LK. This is very, very similar to what we have done in consumer theory also, where I say utility is amount of X into amount of Y.
Ma'am, can you just scroll up?
Anything you want me to clear here?
No, ma'am, I have to write, so.
Okay. Done?
Yes, ma'am, done.
So now just think about this, okay? So consider the utility function that we have been doing till now. Now, none of you asked me this question that ideally I am varying the amount of X. I can change the amount of X that I want to consume. I can also vary the amount of Y. As I vary the amount of X and Y, supposedly, I tell you I consume 4 units of X and 5 units of Y. And then I consume, let's say, 6 units of X and 7 units of Y. This will give me a utility of 20. This will give me a utility of 42. So if I have to really plot this, then, you know, this is what the diagram should look like. X-axis, Y-axis, Z-axis, good X, good Y, and my utility. So I consume 4X and 5Y. 1, 2, 3, 4, 1, 2, 3, 4, 5. And that gives me a utility of 20, which must come on the Z-axis. Then I change X to 6. And I change Y to 7. And that gives me a utility of somewhere here, 42. So ideally, if I start jotting these points down, I must go ahead and I must get a 3D diagram, something like this. I'm not completely making it, but something like this. I get a 3D diagram out of it. Why in the earth then we don't produce it like a 3D diagram and in fact are able to make it into a 2D diagram? How do we get this indifference curve rather than getting this? This is something which we call as the level curve. It is a full-fledged topic in maths. You'll do it. This is known as level curve. Level curve actually holds the value of the function dependent variable as constant. It holds utility constant because U depends on X and Y. It's not required. I should ideally be plotting it like this. But I am able to plot it like this because I say, by definition, holding utility constant at 10. What are the different combinations of x and y? Holding utility constant at 11, and so on. And the reason behind it is just to simply show it in a 2D diagram. That's the only reason why indifference curves are plotted in the first place, because I want to show them in 2D diagram. These 2D diagrams actually, these are the slices of the 3D diagrams by holding this z-axis as constant. So you'll do that in maths. So the point here that I'm coming to is that actually your utility functions, these are 3Ds, but from this utility, when I hold utility constant itself, and then I fluctuate different values of x and y, that becomes 2D, which is a level curve. Why level curve? Because it is holding the level constant of utility. That's why a level curve. Now, same thing can happen here also. I am saying output is labor into capital. Now, you keep fluctuating labor capital, you keep getting different levels of output. So ideally, it is very, very difficult to take labor here, capital here, and output here. And for different labor capital combination, get different values of output. It will be a 3D diagram. To make this into a 2D diagram, we have two approaches in producer theory. First, either you can talk about a short run phase. When I talk about the short run phase, I hold capital constant. We know this from 11th, 12th, that in short runs, capitals are constant. So if capital is constant, then I say output is a function of labor and capital, but capital is constant. So for example, y is L into K, but K is constant at some level. So it becomes y is equal to 10 times L. Now you just plot this between y and L. If L is 1, y is 10. If L is 2, y is 20, and so on. This is the first way of doing it. But what if it is not short run? What if it is long run? Then you hold output constant. So if you hold output constant, then you get y is equal to L into K, but you've held this constant. So then I come back to the same point. Then I want to know all efficient levels. So I say, okay, if I want to hold output constant at 100, what are the different combinations of labor and capital that fetch me this 100? So I just say, okay, 100 is equal to L into K. And I put down different combinations. I say, okay, L is 1, K will be 100. L is 10, K will be 10, and so on. When I do this, then I will get a level curve between L and K. Otherwise, it will be a 3D diagram. So this level curve that I will get between L and K, this will be called isoquant, where iso will mean same and quant will mean quantity. So isoquant means same quantity, equal quantity. So different points of labor and capital, which give me the same level of output: 100, 2, 50, 10, 10, and so on. All of these combinations give me 100 as output. This is an isoquant. So when I talk about a production function, I can only imagine drawing a production function in the short run. In a long run, if you ask me to draw a production function, it will be a 3D diagram. Mostly in your macroeconomics, when I do labor theory, you will always see me drawing something like this. I will say, okay, this is L, this is F of L. I will just have a labor market, demand and supply. Wherever will be my equilibrium, I'll take it up and I'll say this is the output. Because I will assume capital to be constant. Only then I will say that output is a function of labor. If you ask me to draw in a 3D space, which means in a long run, then I will not draw it. Then I will switch myself to drawing an isoquant, which you should know in the background is actually a level curve of production function. If someone asks you why not a production function, because it is 3D, it is difficult to draw. Therefore, from a production function, we want to draw a 2D diagram. To draw a 2D diagram, we want to hold output constant, and therefore what we get becomes an isoquant. If you want to have a look at what are level curves, how do the level curves look, and from different values, how can we computerize and how can we get isoquant or iso or indifference curve, then I have recorded that in your intermediate videos. You can have a look at it. So if you go to your intermediate videos, in my lectures, both for utility and for production, you will see these very, very colorful graphs that will show you these, going from the 3D diagram to the 2D diagram. And I think so there are slides also posted for the same. So you can have a look how you keep on fluctuating, you keep getting 3D diagrams and how you reach the 2D diagram. But this is what the production function is. Now, I want to make a statement before we go ahead. And this is that, this is important, please write down. Efficient production is necessary, but not sufficiency condition for profit maximizing. So since we are talking about production function, which only consists of efficient production, and we know what efficient production is, it only has two kind of points. Either use the minimum input for given level of output, or produce the maximum output for given level of inputs. These are efficient points. Now I am saying that once a firm is on the efficient points, then it is a necessary condition for profit maximization, but it is not a sufficiency condition. So let's elaborate on these two words. Let's understand what is a necessary condition. Necessary condition says that if I am not on the efficient level, then I cannot be maximizing profit. That's the minimum thing. I have to be doing an efficient production for me to be a profit maximizing firm. So if a firm is not on efficient level, it cannot maximize profits. If not efficient, definitely not profitable. But what does the sufficiency condition says? Sufficiency condition says that let's assume that firm is on efficient level. If a firm produces efficiently, then may or may not have maximum profits. Please understand this thing. I am saying that look, agar efficient nahi hai, if not efficient, then definitely not profit maximizing, because it's not even efficient. But even if it is efficient, then it can be an profit maximizing point or cannot be a profit maximizing point. We'll come back to this point a little later again. But just for a second, if I want to go ahead and supposedly I want to, make a statement very similar to this for consumers. Supposedly I tell you that income exhausting bundles are necessary but not sufficient condition for utility maximization of normal goods, good goods. Suppose. Just try and see this. Let's evaluate very similarly. I am saying income exhausting bundle are a necessary condition, which means if I don't exhaust my income completely, then definitely I am not maximizing my utility, which is correct. So just consider this. If this is my budget line, where is my maximum bundle? Where do I lie? Where is my utility maximum? Where I achieve this tangency. Tangency is achieved on the budget line. Can I ever have maximum utility below the budget line? Here. No. It is always on the budget line that I maximize my utility for good goods. Always on the budget line. So which means being on the budget line is compulsory. If you're not on the budget line, you cannot be having maximum utility. So it is necessary to being on the budget line to exhaust your income. But is it sufficient to be on the budget line? It is not. I am on the budget line even at this point, even at this point, even at this point, even at this point. But these are not maximizing my utility. Only this point is maximizing where I have the tangency condition met. So it was necessary to be on budget line to classify the first point, but not all points on the budget line would maximize my profit. Same. It's not possible, right, that the bliss point is below the budget line, because I'm talking about good goods. I, as a rational human being, will always exhaust my entire income. That is what I would be doing. I want as much of the good as possible. So I want to exhaust my entire income. If it is a good good, my bliss point will always be above, right? It cannot be below. This is the only case that I've taken good goods. Yes. So that is exactly what I'm saying here also. I'm saying, look, if you want to maximize profit, this is the minimum thing that you have to do, that you have to produce efficiently. And which points produce efficiently? Only if you're on the production function. When are you on the production function in the long run? Only if you're on the isoquant. because this isoquant, this is actually in a way production function, which means this is saying that I must be on my isoquant for me to produce efficiently. But not all points will be the profit maximizing point. Only one point on the isoquant will maximize my profit. So it's not a sufficiency condition. We'll deal with all this details later. But for now, you just have to try and understand the meaning of necessary and sufficiency. So please write down. This is important. Write down, if you are producing, let's write down, if you are not producing efficiently, then you cannot maximize profits. This is necessary sufficiency. Even if you are producing efficiently, then that point may or may not be profit maximizing. Right? It may or may not be profit maximizing. So these two conditions become important. Now, when we come to the output side, I just want to do 3 definitions before I end. There are 3 definitions that we would like to know. The first is total product. The second is average product. And the third is marginal product. The total output that a firm produces is total product. Average product is output divided by input. Marginal product is how output changes when input changes, or change in output due to change in input. So we can say that if I have a function of labor and capital as the output, when I divide it by labor, I get average product of labor. If I have a function of labor and capital, when I divide it by capital, I get the average product of capital. How this function changes when labor changes, this is the marginal product of labor. And how this function changes when capital changes, this is the marginal product of capital. And this function itself, output as a function of labor and capital, this is my total product.